Hello, welcome to MRP classes. Today let me discuss very important topics in uh, so- very important topics in solid state. I will introduce you some relations that will help you to solve many numerical questions in a single shot. This is the chart. Important relations in solid state. This is the chart. Here I give you first simple cubic. Let us simple cubic. Simple cubic edge length is a by 2. Distance between neighbor, nearest neighbor. Distance between nearest neighbor is a by 2. Radius of lattice point of simple cubic unit cell is a by 2. Edge length a. Distance between nearest neighbor a by 2. Radius of lattice point a by 2. Now I go to the next one, FCC or CCP. What is the, here I use face diagonal. Face diagonal. I will introduce you the face diagonal. That is root 2a. Edge length a, face diagonal root 2a, where a is the edge length of the unit cell. Distance between nearest neighbor, nearest neighbor, nearest neighbor root 2a by 2, half of this face diagonal. Radius of the lattice point is root 2a by 4. Look at here, root 2a by 2, root 2a by 4. Face diagonal, distance between nearest neighbor and radius of lattice point. Root 2a by 2, half. Again half, root 2a by 4. Now we can go to BCC. BCC, look at the BCC. Yes. Body diagonal. Here body diagonal root 3a. Distance between nearest neighbor, root 3a. Radius of lattice point root 3a by 4. Therefore this is in short simple cubic a by 2, a by 2, where a by 2 is distance between neighbor, a by 2 is radius of lattice point. Face diagonal root 2a, distance between nearest neighbor in FCC or CCP is root 2a by 2. Radius of lattice point is root 2a by 4. BCC body diagonal root 3a, distance between nearest neighbor in BCC is root 3a by 2. Radius of lattice point is root 3a by 4. Understand, a is out of the root. Now I will show you what is this. Suppose you have a simple cubic unit cell like this. Simple cubic unit cell like this. Okay. Your lattice points are here. Lattice points, lattice points, lattice points, lattice points, lattice points, lattice point. This is the lattice point only at the corners. Be careful, even though we have drawn like this, but it is touching each other, touching each other. Therefore, this is the half distance, half r. This is also r. Therefore, edge length is here 2r. Edge length is 2r, where r is the radius. Therefore, radius is equal to a by 2. Now, let me go to what is a face diagonal. Face diagonal. How do you get the face diagonal? Okay, imagine a unit cell like this. Okay, yes, suppose this is a face. You have a particle here corner, you have a particle at the this corner, you have a particle at this corner, and you have the particle at this corner. Here the particle at the face. Therefore, let me introduce four particles. These are the this is the particle in the center of the face, this particle, and these are the particle at the corners. Corner particles are not touching each other. Okay, these are the corner particles. Therefore, their centers. Look at the centers. Yes, you can make, this is, look at here, R, here R. This is 4R. Face diagonal is equal to 4R. This is A, this is A. Yes, therefore 4R is equal to, look at here, 4R. Now you can produce hypotenuse theorem. A square plus A square is equal to R plus R. This is R plus R is equal to hypotenuse. This is face diagonal square. Face diagonal square. Therefore 2R A square is equal to 4R, or A square is equal to 2R square, or R is equal to A by root 2. A is equal to A square by 2 is equal to R square, or R is equal to square root of 2 square root of A by 2. Okay, this is the answer. This way you are getting this. Or face diagonal is equal to face diagonal square is equal to, now another relation, look at, I bring this relation here. Face diagonal square is equal to 2A square. Therefore face diagonal is equal to root 2A. These are the relation we are developing. Now we can go to body diagonals. BCC. Look at the BCC unit cells. Again, BCC unit cells like this. You have a particle at the center of the body, and you have a particle at the corner which is touching this center particle, and you have a particle at this opposite corner. Therefore, if I draw like this, now this is the body diagonal and this is the face diagonal, and look at this edge length A, face diagonal, and this is the body diagonal. Therefore face diagonal square is equal to, face diagonal square plus A square is equal to body diagonal square. What is the face diagonal? We just proved face diagonal square is equal to 2A square. We just proved face diagonal square is equal to 2A square plus A square is equal to body diagonal square. That is 3A square is equal to body diagonal square, or body diagonal is equal to root 3A. Body diagonal is equal to root 3A. Therefore these relations are once again body diagonal root 3A, face diagonal root 2A, edge length A, distance between nearest neighbor in simple cubic A by 2, in face diagonal FCC or CCP root 2A by 2, and distance between nearest neighbor in BCC is root 3A by 4. This is the radius of lattice point in simple cubic A by 2, root 2A by 4, and root 3A by 4. Now let us see some questions, simple questions. Look at this question. Gold R radius is 0.0144 nanometer, crystallizes in a FCC unit cell. What is the length of side of the cell? They are asking you what is edge length. Question is what is A? This is the question. FCC radius is given. This is equation root 2A by 4. You want to calculate what is A. For that 4R into root 2A. Substitute the value of R, you will get this answer. Okay. Now the next question, see this question. In a FCC lattice, edge length of a unit cell is 40 angstrom. Edge length is given. What is the closest distance between gold atoms? Nearest distance, closest distance. Distance between nearest atoms. That is the question. Distance between nearest atoms in FCC is root 2A by 2. A is given. Please do the calculation. You will get the answer. Okay. Distance between nearest neighbor in FCC is root 2a by 2. Substitute their value, you will get the answer. See this question. A compound XY crystallizes in BCC. Please, BCC. Lattice with unit cell edge length 480 picometer. If radius of y minus is 225 picometer, then radius of x plus. Therefore, we assume that y minus forms present at corners and x plus present at x plus present at corners, y minus present at the center of the body. Okay, you can have a different, no problem. Anyway, it's a BCC, its edge length is given. They want to know radius of y minus and radius of. Here, please understand. Imagine this is the body diagonal. This is the body diagonal. What is the body diagonal? It originates from one corner, goes through the center of cube and meet at the opposite corner. This is the corner and this is opposite corner, and this is the body center. The particle at the body center is suppose y minus, here x plus, here also x plus. Therefore, this is a body, it's a 4r, but this r and this r is cation radius 2r plus, that is 2r plus this r and this r are uneven, 2r minus, y minus present at the center of the body. Therefore, you can have a relation body diagonal is equal to root 3a. Therefore, 2r plus 2r minus is equal to root 3a. 2r plus is you wanted to calculate. Therefore, r minus is given 2 into r minus 225. Please do the calculation, you will get the answer. Therefore, thank you for watching. This equation will help you to solve the questions in a single shot. Please click the subscribe button for more videos.